Altux CT provides an intuitive graphical user interface to process CT data. The purpose of this video is to train a new user. We will go through the typical workflow of generating a cone beam CT reconstruction. We provide training on the following components: installing the software, inputting the CT data, detector gain calibration, automated geometric calibration, region of interest selection, and image reconstruction. For training on the sequence viewer and 3D viewer, please watch the next video. In this section, we will go through the basic installation process. Before installing Altux CT, please make sure your system meets the minimum specifications found on page 3 of the manual. The Altux CT installation requires administrative privileges. Please make sure you have administrative privileges. Locate the installation file, altuxsuiteinstall.exe, and move it onto your local drive. Click on the file. Extraction of the files will begin. At this point, prerequisites may be installed. Follow the instructions on Install Shield Wizard to complete the installation. After the installation is finished, the Altux shortcut will appear on your desktop. Before proceeding to the next step, copy the tutorial data to the local C drive. Once the software is installed, launch Altux CT by double-clicking on the Altux icon on your desktop. The LT Launch panel will appear. From the Plugins menu, select Cone Beam Tools. Once loaded, a window will appear. In addition, a device optimization dialog box might appear depending on whether or not the GPUs have been optimized. Select Yes when prompted. Now we input the settings file from the CT scanner to provide the software with the required parameters. Click on Input CT Data. Navigate to the directory where you copied the tutorial data and locate the file named precmotor1.nsipro. Currently, we support the following CT vendors and extensions: Northstar Imaging.nsipro, General Electric.pca, Exelon.config, VJ Technologies.raw, and Nikon.xtechct. We're continuing to add to the supported vendor list. In this tutorial, we will be using the Precmotor1 dataset that was obtained using a Northstar Imaging CT system. Once you have selected the settings file, click Open. You will notice the information at the top of the GUI has populated with key CT parameters. The next portion of the workflow is used to perform gain calibration. For Nikon datasets, the gain calibration step is optional, and you may go directly to the Pre-Reconstruct section. Now click on Perform Gain Calibrations. The software will begin correcting the projection data. If applicable, the software will apply detector gain, offset, and bad pixel maps to the original projections and output them in the corrected radiographs folder. All datasets will be calibrated for the X-ray CT air value, also known as the background intensity. Next, click on Input Geometric Calibration. A new window will appear. Initially, the parameters are automatically populated from the settings file. Note that for most vendors, this step is optional. The user can manually change a variety of parameters based on the geometry of the CT system. This includes magnification, image center, detector pitch, stage rotation, and tilt. The software can also calibrate these parameters automatically. Notice that by default, the X-center calibration is set to fine. This will calibrate the X-center using a coarse calibration followed by a fine calibration. The user can select coarse or fine for source to object, X-center, Y-center, and tilt. Click on the Calibrate button. The Select X-center calibration will run, and the new value will populate once complete. To close the window, click Finished. Next, click on the Pre-Reconstruction tab on the left and click Pre-Reconstruct. The software will run a coarse reconstruction of the volume so the user can select a region of interest. Once completed, click on View, select ROI Volume. A dialog box will appear with directions. Click OK. A new window will appear with a tool that provides 3 maximum intensity projection images for choosing the region of the data that will be reconstructed. Click and drag the side or corners of the red rectangular graphic to designate the region of interest or ROI volume. Note, when using FEMOS or FDK scatter-corrected reconstruction methods, choose the ROI to encompass the entire object and also a small empty margin around the object. This will produce reconstructions with fewer artifacts. Click the Set ROI button when done. Now, click the Reconstruction tab on the left and make sure that the FDK button is selected. Click Execute. If no files are present in the default directory, the software will begin processing. Feldkamp-Davis-Kress is the traditional algorithm for reconstructing CT images. Once completed, select the FEMOS button. Leave all parameters at the default setting. Click Execute to start CT reconstruction. FEMOS is an iterative algorithm that is capable of improving resolution, contrast, and compensating for CT artifacts. The speed accuracy slider can be used to adjust the trade-off between speed and quality. If the Use Scatter Removal box is checked, FEMOS will reduce beam hardening and scatter effects from the CT reconstruction. Once completed, select the FDK Scatter Corrected button. Notice that the Use Scatter Removal button is checked and grayed out. This is because the FDK Scatter Corrected algorithm only works with the scatter reduction feature. Now, click Execute to begin the CT reconstruction. FDK Scatter Corrected combines FDK and FEMOS. It runs much faster than regular FEMOS. Finally, click the View Output tab on the left. This will bring up the different viewing tools available in the software package. The Sequence Viewer helps users analyze individual CT slices. The 3D Viewer allows the user to view the entire volume and perform image adjustments. For more details, please watch our separate training video on the viewing tools. The Cone Beam GUI has several menu options. To view the installation instruction and user manual, go to Help, Tutorial. You can find more details on everything we covered today in this software manual. For more information on menus and advanced features, please watch our separate training video. This concludes the training video on the main components of the Cone Beam tools in the Altux CT software package. If you have any questions, please contact customer support at support@lickenbrock.com.